Let's continue with the logical operators themselves. The logical operators are mostly used when you want to compare two conditions. Let's say that we have two variables that represent dimensions and we want to create a matrix based on these two dimensions. But we are very picky and we want to use the first dimension for rows and the second dimension for columns only if one of the dimensions match our desired dimensions. Now, since we have two dimensions and we want to check both of them, that means that we will have two conditions. So our first condition will be checking if our first dimension is equal to 3, and our second condition will check if the second dimension is equal to 5. Now we need something in between these dimensions. Since we want at least one of these two dimensions to be true, this means that we have to use the OR operator. So OR. And also, as you can see, I have used brackets around each of these expressions. I have used brackets because brackets, just like in arithmetics, actually let's not suppress it and let's run it, and there we have it. Now if I change our first dimension to something else, let's say a 7, we still get our matrix, we still get a 7 by 5 matrix, but our first condition is no longer true. The second condition, however, remains true. The second dimension is still a 5, so as long as at least one of these two conditions are true, we are going to have our code in the if block executed. In order to transform our OR condition into a NOR condition, we simply need to negate it with a NOT operator. We need to negate the whole condition. And to do this, we need, I'm simply going to copy and paste it. To do this, we need it the NOR condition will execute its code only if both of these conditions are false. If I run the code now, we are still in the first case, in the first scenario, because one of the conditions is still true. Now, if I change this condition to be false, so any number other than 5 will do the trick. So if I make it a 4, we are now in the second condition. Actually, let's switch this so that it can be more apparent. So second dimension, and here we want to have the first dimension. So if we are in the NOR condition, we will use the second dimension for rows. If we are in the OR condition, we will use the first dimension for rows. And there we have it. Now we have 4 rows and 7 columns. If I switch this back to 5, we get 5 columns and 7 rows. So this is OR and this is a NOR condition. Now let's move on to AND and NAND. Now let's say that you have some complex calculations and you want to check the resulting value if it's between a given range of values. Since we're not dealing with complex calculations in particular, I will just generate a random number between 1 and 100. So round I, 1 to 100, 1, 1. So just one number. Let's see what the number. And I want to check if that number is in the range between 20 and 40. So I'm going to say if the number, so first a set of brackets for the whole expression. Next, our first condition, number bigger than or equal to 20. Our second condition, number less than or equal to 40. And in between, we have to use the AND operator because we want to check if the number is in that range. If we use the OR operator, we will get a true result basically for any number because if you get 30 the number 30, for example, it's both more than 20 and less than 40, but if we get a 50, it's more than 20 and it's more than 42. So with the number 50, we will not pass this condition, but if it was an OR condition, it would have passed it. So if you want to specify a range of values in which you are interested in, you have to use the AND operator in this fashion. So if the number is within our conditions, we want to multiply it by pi. So number times pi equals number times pi. If the number is not in that range, so else, so any other number that is not in that range, we are going to divide it by pi. Divide by pi equals to number divided by pi, and finally an AND. Let's press these things here. Let's run it. So we get the number 94. The 94 is not within our range and it was divided by pi. Let's try again. 68, still not in the range, still not in the range. There we have it. 40 is within our range and it was multiplied by pi. Let's try again. So 28, there we have it. Another number that is within our range and it was multiplied by pi. Now, the NAND condition, as we have discussed, will execute our code if at least one condition is false. That means that the else block will execute every time the number is not in our specified range. So let's copy and paste this. Again, we are simply going to negate the whole expression. And now, if we run this, you can see that the operations are reversed. We get the number 5 with the AND condition, we divided by pi. In the second, where we are using the NAND, we're reversing it, we're multiplying it. If we go again, there we have it. Now the operations are reversed because the number is within our range. And first we are multiplying it here, then we are dividing it.